Hello YouTubers. Well, here's an interesting little problem I've come up against, and how I'm going to solve it might be interesting to some of you out there. This is a stepper motor. It came off of a CNC lathe, and it's an old piece of industrial equipment, 1970s, late 70s, early 80s vintage that got scrapped. And I saw the lathe in operation before it was scrapped, and this is a potent little motor. It's fairly large, stepper motor, got a lot of torque to it. The problem is the number plate on it is in some foreign language I don't understand, and I managed to figure out the model number of the motor off the number plate, and all of my Google searches just turn up Chinese websites that Google Translate does a really crappy job of translating. So basically I can't find any real information about this motor, but I would like to use it because I have several of them, and like I said, they're nice little torquey motors that I could put to good use. Now, I cut the connector off of it because I was going to want to use a different kind of connector, and it's an 8-wire motor. There are 8 wires coming out of it, hence it's an 8-wire stepper motor. And I did a little preliminary work with my trusty multimeter here and probing the wires, and there are, 8 wires, and sure enough there are 4 coils. There are 2 wires for each coil, and I've written down here that the white and blue constitute one coil, the yellow and the gray constitute another, purple and red constitute another coil, black and green are another coil, and these 4 coils are completely separate. They aren't interconnected. So, okay, it's an 8-wire stepper motor, and being an 8-wire stepper motor, it's going to have a configuration similar to one of these 2 right here, and I'm going to want to wire it up in a series configuration like the motor on the right there is wired up. So I have got to figure out the coils. I got to figure out which coils belong to the A phase, which coils belong to the B phase, and I've got to figure out the polarity of the 4 coils so that I can wire them up correctly to my stepper motor controller. So how can I do that? Well, like I said, I've done some of the preliminary work with the multimeter, and with a lot more probing and trial and error, I could probably figure it all out just with the multimeter. But there's an easier way. If you have an oscilloscope, a 2-channel oscilloscope, you can easily sort out the coils on an unknown 8-wire stepper motor, and I'll show you how to do that. So how am I going to use the oscilloscope to help me figure out this motor? It's got 4 coils connected to 8 wires. Those coils have to be divided into 2 phases, and the polarity of the coils has to be determined so I can hook them up in parallel or series, whichever I want to do. So how am I going to do this? Well, I already used my multimeter to buzz out the motor and figure out that there are 4 coils in it connected to various wires, but that really doesn't tell me too much. It just tells me, okay, that say the white and the blue wires are one coil, the yellow and the gray wires are another coil, purple and red are another coil, and the black and the green are another coil. But that doesn't tell me anything about their phase, doesn't tell me anything about their polarity. So what I'm going to do is I'm going to use the oscilloscope, and the motor will act like a generator if I turn it. So if I just arbitrarily take channel 1 of the oscilloscope and I hook it up with the probe on the white wire and the ground clip on the blue wire, now I know that's 1 coil. I don't know what phase it is. I don't know what polarity I have hooked up to it, but I know that's 1 coil. Now if I turn the motor, it's going to act like a generator, and there you see we get a nice little sinusoidal signal out of it as I turn it. So if I hook the other channel of the oscilloscope up to another coil, I will see one of 3 things. Either that coil is going to put out a sine wave that is in phase with the first one, or is 180 degrees out of phase with the first one, or is 90 degrees out of phase with the first one. So if it's 90 degrees out of phase, it's going to belong to the other phase. I'm going to call this first one I'm hooked up to here, I'm just going to arbitrarily call this phase A of the motor. So if I find one that's 90 degrees out of phase with that, I'm going to know that that belongs to phase B. If I find one that is either in phase with this one or 180 degrees out of phase with it, I'll know that it also belongs to phase A. So let me hook up channel B to another coil. So I'm going to hook up right now, I'm going to hook up arbitrarily to the black and the green. I'm going to put the scope probe on the green wire and the ground clip on the black wire. So now when I turn the motor, we should see two different sine waves. And there they are. And look, they are 90 degrees out of phase. So if the first one I was arbitrarily calling phase A, then this second coil is part of phase B. So I've got my little notepad right here and a pencil, and as I go along I'm going to mark out that, hey, this one is phase B, part of phase B. So so let me find another coil. Let me go to, let's see, yellow and gray. Okay, so now if I turn it, and I'm leaving channel 1 on the first coil I had it on. So I'm just comparing the other coils to it right now. Oh, look at that. We're 180 degrees out of phase here. So that tells me that this coil is on the same phase as the first one, but I have the polarity swapped. So let me write this down, that the yellow and gray wires are part of phase A, and the polarity is opposite of what I had before. So if I swap the wires, swap the ground wire and the probe around for that second coil, and then turn it again, look at that, they're perfectly in phase now. So it looks like I've sorted out phase A. So I know which two coils are phase A, and I know the polarity that needs to be set up. I know that the white and the gray wires are going to be polarity 1, and the blue and the yellow wires are going to be polarity 2. So I've got that all marked down on my notepad. So now I can go back and let me find the other phase. Let's see, I figured out that the black and the green wires were part of phase B. So let me hook up channel 1 to that. Black and the green. So I'm going to put the channel 1 on the black and the green wires with the ground probe on the green wire and the probe on the black wire. So, and then the other coil that I haven't probed yet is the purple and the red. So let me hook up to that. So there's the ground clip on the red wire and the scope probe on the purple wire. So this should be the two coils in phase B. So let me give the motor a spin. Oh, look at that. They're 180 degrees out of phase, so they are both phase B coils, but I have the polarity swapped. So let me swap the polarity on channel 2. Let me hook the probe up to the red wire and the ground clip up to the purple wire. And now I'll bet when I spin it, yeah, they're perfectly in phase. So now I know that the purple and the red and the black and the green are wires for phase B, and I know they're phasing now. So I know that purple and green are phase 1 and black and red are phase 2. Or I'm sorry, polarity 1 and polarity 2. So now I've got it all sorted out. Writing it down here on my notepad as we go along. So I know exactly how to wire up this motor now. So we'll see just how smart I am in a little bit. I'll hook it up to my stepper motor controller and see if it moves based on the sorting out I just did. But I'm pretty confident it will. So Hey, that's pretty good. In less than 20 minutes, I went from not knowing anything about this motor to knowing exactly how to wire it up. So, I love my little oscilloscope. It comes in very handy for so many things. Back shortly. Okay, so how did I do? Did I guess right? Get all the wires right? The phasing right? Everything? Well, let's find out. So here I have the motor, and this spaghetti of wires down here is all connected up to a stepper motor controller, which in turn is connected to a power supply, which in turn is connected to my laptop running Mach 3. So, if I got everything right, if I was to jog the z-axis, because I have this motor attached to the z-axis output on the stepper motor controller, so if I was to hit the button over here to jog the z-axis, let's see which button is it, this will do it, then the motor should move. What do you know? Does it go the other way? Goes the other way too. Not sure I have the current settings right for it yet, because it seems a little bit rough, but it's working. It's working. It's got a lot of torque too. It's got a whole lot of torque, which is what I was hoping for, because I wired it up with the coils in series for more torque, because this is going to be running the z-axis on my new CNC mill, and it needs a lot of torque to turn that. So there you go. That's how you sort out the wires on an unknown 8-wire stepper motor. Not too difficult. I hope that helps you out if you're in a similar situation where you've got a motor you need to sort out the connections on it. Anyway, thanks for watching, and check out my other projects on my website at mdpub.com and my other videos on this YouTube channel. Bye.